This video is for lesson 5.3. This video specifically covers example 1 and example 2, which we did in class. So you don't need to watch this video unless you didn't get those examples down in your notes. So for example, if you were absent, you should watch this video and do examples 1 and 2. Example 1 says solve this equation. It's a rational equation because we have fractions on each side and they're set equal to each other. So that makes it an equation. Up until now, we've been working with expressions, so there was no equal sign. We were just simplifying. Now we're going to actually be solving for x. In this first example, we have just a really basic rational equation, and we can solve it by cross-multiplying. So we're going to multiply 4 times 2x plus 1. And then multiply the other direction, and we've practiced this many times in geometry. We have 5x minus 1. And then we distribute. So 4 times 2x is 8x, and plus 4 equals 5x minus 5. I'm going to subtract 5x and subtract 4. And I get 3x equals negative 9. So x is equal to negative 3. Okay, now it's important when we're doing rational equations to do a check step to make sure that our answer works and makes sense. So we can do a check step by plugging x into the original equation. Don't plug it into the cross multiplication, because if you made a mistake in this step and you plug it in, it'll look like it's okay when it really isn't. So let's plug our x value in. So it's 4 over negative 3 minus 1. And we're testing, is that equal to 5 over 2 times negative 3 plus 1. So this is 4 over negative 4 equal to 5 over negative 6 plus 1. Negative 6 plus 1 is negative 5. So both of these equations are equal to negative 1. So this checks out. Negative 3 is our answer. All right, let's move on to example 2. This example is a little more complex. We can't just cross multiply because we don't have two fractions that are equal to each other. We don't have two ratios equal to each other. So we are going to solve by finding the least common denominator and multiplying. So this is somewhat similar to method 2 that we use to simplify complex fractions. So let's first identify the LCD. In this case, we have 3 in the denominator and x. So our LCD is 3x. So I'm going to multiply both sides of my equation by 3x. And then I have negative 2 over x times 3x. You could write it as 3x over 1 if you wanted to, but you don't have to. And then I'm going to distribute. So I get 3x times 5 over 3 plus 3x times 3 over x equals negative 2 times 3x over x. And now I'm ready to start canceling. My 3 and 3 cancel, x and x cancel, and x cancel, leaving me with 5x plus 3 times 3, which is 9, equal to negative 6. So remember, when we cancel, we can only cancel inside of fractions, and we can only cancel if it's factored. And these fractions are factored because it's just things being multiplied to each other. So 3 is a factor, x is a factor, 5 is a factor, etc. All right, now that we have it as 5x plus 9, we can just solve this basic equation. So I'm going to subtract 9. I get 5x equals negative 6 minus 9, which is negative 15. So x equals negative 3. All right, so x equals negative 3. So again, we want to do a quick check step. I'm going to clear the page so that we can do that. All right, so we had negative 3 for x. And let's actually check that. So 5 over 3, 5, plus 3 over negative 3 equals, with a question mark, negative 2 over negative 3. Okay, so we have a negative 3 in the denominator here. We can move the negative to the numerator and get rid of it in the denominator because it's just equivalent to negative 1. The negative can be in the numerator or the denominator. It doesn't matter which one. But now that we've moved it, our denominators are the same, so we can add these things together. We have 5 minus 3 over 3. Is that equal to 2 over 3? Because a negative and a negative will cancel out. Yes, this is going to become 2. So we have 2 over 3 equals 2 over 3. So negative 3 checks out as an answer. That's it for the examples. Next up, there are 2 practice problems. You don't have to do them, but I highly recommend doing them. If you do them, the answer to number 5 is x equals negative 6. The answer to number 8 is x equals negative 3. Now, it's not required, but I highly recommend that you do the check for understanding. If you do the check for understanding, it's in a box on your notes. You'll find that x equals 2. And the important thing here is the check step. So the original equation was 5x over x minus 2 equals 7 plus 10 over x minus 2. When we go to do the check step, and I go to plug this in, and I have 5 times 2 over 2 minus 2, and we're testing, is that equal to 7 plus 10 over 2 minus 2? We get 10 over 0 equals 7 plus 10 over 0. Now these things are obviously not equal, but the bigger problem is that you have a denominator of 0. If you ever do your check step and get a denominator of 0, you know that the solution does not work. You can't ever have a denominator of 0. So we can cross this out. This is what we would call an extraneous solution. So it's not a real solution. It looks like one, but it isn't one. It's an extraneous solution. So in your homework, if you have an extraneous solution, you can say it's extraneous, or you could just write no solution after you've checked the answer and it doesn't work. So an extraneous solution or no solution. So put that in your notes for the check for understanding. Next up, there will be a separate video for example 3 and beyond.